Welcome to Router Door Basics, where we're going to make advanced doors with basic tools. We're taking a look at a number of ways of making these doors up so that you can, at home, build some of the nicest doors that you could expect to find on any commercial cabinet. There are a number of different cuts we can make. We're going to see all of these in the tape, joinery, and a number of other aspects of the door construction. Before we get started, if you view this tape and you find that maybe you're not up to speed, you might want to consult with my videos 104 and 105 in the series, Basic Door Construction and Advanced Door Construction. They'll give you additional information to help you see the big picture here, although this videotape will stand alone and help you go. So, let's go get them. In making up router-made doors, there are a number of things that we have to do to join the parts together. The way we join them can vary from one technique to the next. In working with this joint today, we're going to start with the biscuit or plate joint. The biscuit or plate joint actually uses a little wooden disc inside the joint to fit it together. There are a couple of different types. One is a smaller one, like so, thicker than this one. So we have a narrower, that is not too wide this way, but fairly thick piece, which penetrates both parts a little deeper. This one is thinner and wider. So if we're designing a door, this joint could be used on this door, which uses narrower parts. If we want to avoid seeing this one, of course we're going to have to use a wider part to mate these up to make this fit. Otherwise, what we're going to do is see that inside the door, which may be undesirable. In this case, we're going to make the frames up a couple different ways, show you how we go about this, and then we're going to route these so that they will accommodate a panel. Some of these techniques may be new to you, so you can back up and repeat these if there are some questions. Let's take a look at one of the first techniques, which is with a router bit. Many of you are familiar with the plate joiner as a tool, and we can buy these plates like so, and you can put them in with a plate joiner, or we can use a router bit, a slotting router bit such as the one you see here. It will cut a slot exactly the same size as the biscuit. In other words, the carbide tips on here will cut a kerf that accommodates that biscuit perfectly. So in using this technique, we have only the purchase of a router bit and not a plate joiner, and we can do this exact setup. Let me go through some of the steps now, and then we'll proceed to route this. One of the first things we have to do is lay out our pieces and mark them. Now, we'd have to determine the dimensions depending on what type of door we're working with. Then we have little pencil lines here that mark the center lines of all the parts. If we're really being particular, we can mark these, especially if color was important here. For example, we have X's here, but we might call this A, and then we can call this B, B. And now we'll be able to bring these parts back together so they always fit together correctly. To route these, we've got to do a few things to work safely and to work smart. We'll clamp these on the bench like so that we can route these slots into the edges. The clamping will be done with just a small bar clamp such as you see here, or any other clamp that you might have available. In addition, we'll add a clamp pad, which is something to hold the piece and protect it from being smashed as we tighten the clamp. It's a good thing to check to see if they'll spin. If they'll spin like this, you need to snug that clamp up just a little more, much better. You could clamp all the parts, but for the sake of demonstration, we'll only clamp two and get set up with the router. I've got my router preset for the right depth. I have the good faces of my boards up. That way, the good faces will all line up when they're joined. Any irregularity in stock thickness will actually be compensated for on the back of the piece rather than the front. I'll need my ear muffs to protect my hearing, a pair of goggles so I can get in close, see what I'm doing, and work safely. Let me get a cord prepared here. First, make sure your router is shut off before you turn it on, or plug it in, I should say. Next, I'll set my goggles and muffs. Now what I'm going to do is set this on here, and I'll be able to look in and I'll see the center line of the mark here, and I'll be able to bring the center line of the router bit in on that mark. The ball bearing here will stop me when I get my true depth. From there I'll go over and do these two as well, and then we'll stop and take a look at what's happened. Now you may be concerned that I wasn't really accurate in my settings. That is, I just eyeballed the center line. Yet, because of the nature of these biscuits, they will slide in the slot. So I shouldn't have any problem joining them. There is enough latitude in these biscuits that when I put them in, I can slide them laterally slightly and still get the desired joint that I want. So this technique uses a router bit to make a plate joint. It's very easy to make, requires a minimum amount of equipment, and it's quite convenient. It's a little clamping, but time-wise we can put this together in short order. Now what I'd like to do is show you another method with a router table that allows you to use these bigger biscuits such as you see here. Bigger in the sense they're thicker but shorter. We can now use a narrower piece of wood to make this up. And what I'll do is I'll demonstrate that technique with a router table. It'll take me a minute to get my router table set up, so I'll meet you back here at the bench in a minute. We've set up my router table now, and we've done a few things with it to make this biscuit joint cutting easier. What we're going to be doing is taking our center line mark, lining it up with a bit, and this stop will hold our position. We're going to feed in, and there'll be no problem with control because the ball bearing on the bit lines up with the fence. You'll be able to see that here in a second. We'll feed in, we'll make that cut, and we'll flip it around and make the opposite end of the cut. Now, for the vertical pieces of the door, the stiles, we'll be able to make the cut on one end, but obviously we can't make the cut on the other end until we change the setup. So I'll make all the cuts I can first, and then I'll show you the way to change the setup. The slot is cut cleanly in this method, and as I look at it, my center line lines up perfectly with the center line of the slot. So I'm real happy with what's happening. Now, what do I need to do to make the next setup? Well, the first thing I want to do is unplug my router from the machine, since I'm going to be, or from the power source, so that I won't have any chance of accidentally turning it on. Next, I'm going to loosen this clamp here, remove it. And I'll position my piece. I've got that pencil line here. I'll position that under the center line of my guard, like so. And that will help me position my stop. Now I think what I'm going to do is position my stop this way, since it's going to be easier to clamp it and control it. Much better. You'll note that the line on our board lines up with this line that's been etched in our barrier guard, which also lines up with the center line of the router bit and the center line on our fence. This assures us then that when we position our stop, it is in the right position. We can butt against that and make the cut. So everything's set up. I've locked the fence with a good clamp, or the stop, and the fence is clamped securely, so I can proceed to make the cut. There's a bit of tear out here, but that won't be a problem, because as the mating piece butts up against this, that'll disappear. So we're not going to concern ourselves with that. This is the setup for making the plate joints or biscuit joints with a stationary router table. Now that we've cut all of these, we'll go back, remove this, I'll dismantle this, and we'll set up, and I'll show you how to clamp these up so we get a nice, tight, good fitting door or panel ready to, or door frame that will accept a panel. So I'll get that ready now. We cleared away the router table, and I've dry clamped everything in these two doors that we put the plate joints in. The way things are set up, it's a matter of loosening the clamps, and you're probably wondering why I clamped them to begin with. Well, I like things set up, and I want to make this as easy as possible when I go into it. So I've set these aside like so. I can flip these up like this, and then I can squeeze a little glue in here. And then brush the glue on. It's important that you wet the opening. We'll slip these in now. And how much glue is enough? Well, you don't want to overdo it, because if you do, it's going to squeeze out and it's going to be very difficult to control. So I've been intentionally going light. Now I can look, I see my lines are pretty well lined up. It's not a perfect fit yet, but that's not a problem. I can move them into position very easily with a hammer or mallet if I need to. And I'll show you that in just a second. So, brush the glue in. The end grain isn't as important as the edge grain, because the end grain doesn't do a lot of holding. These will start to swell once the glue hits them. And so you have to work fairly quickly once you get going here. So I'll push this around, flip it over just like that, tap it down, bring it back into the clamps, and gently snug these up. I don't want them too tight yet. Here's why. I want to be able to tap this a little bit so that it squares up. Then I can start to snug the clamps just a little bit more. Check for square. Things are looking pretty good. Another approach to checking for square is to measure the diagonals. I'm about 32 short of 16.5 both ways. If I were a little long on one of these, I'd put a clamp diagonally on the longer one, snug it up lightly. Okay, so that's the clamping procedure. Not too much glue. Work carefully, work with some speed. I could go ahead and glue this one up. I'll set this one aside. We'll come back. When you see me next time, I'll have both of these set up and ready to route. We're going to make up some moldings, and we're going to use these to hold our panels in the door. And we'll see a little bit more about that later, but let's make the molding for now. Notice that we've got two beads formed here, and then a rabbet cut on the bottom. Right now what I'd like to show you is how to make these beads. We've set up a cutter in here protected under the shield, and it cuts half of that bead. You can get an idea of what's being cut as this goes through like so. Then after that's cut, we flip the piece over and we make another cut, and that forms the opposite side of this. So it takes two passes to make that bead, yet the beauty of it is that you only need one cutter. Your costs stay low, and I think that's an important dimension. Now the piece we're going to be using is a little more substantial, and that's good because we're taking quite a bit of wood away. We've set these feather boards up so they put a little bit of drag on the piece and also take the bounce or the vibration out of the piece. Look your stock over before you make any cuts. You want to cut with the grain whenever possible, and you also want to cut your best side. You want the best grain out because that's the side we're going to showcase. All right, I've set up my cutters. I've got to plug in my machine, put on my muffs and so forth, and I'll be ready to go. Well, we formed our two beads on top, and it looks like the desired molding except for one final cut, and that's the rabbet cut or the L-shaped notch on the underside of the piece, and we're going to set up to do that now. We've rabbeted this piece, and that'll be the molding we'll be using to hold our door panel into the door. Now, what I've done is I've set up my spiral bit, a 1/2-inch spiral bit, and I've positioned it so I'll be making this cut feeding through here like so. In fact, this was the test that I made up to that point. Now, we'll make several feet of this molding so that we can miter this and use it around the door, and its use will become evident as we get into the door construction. So I'll go through the actual fabrication of this now. If we were running this, we would probably run 50 to 100 lineal feet depending on what kind of doors and how many we have. But this channel, this L-shaped channel, matches the setup with the panel. And what's the depth? Oh, about 1/8. What's the width? Oh, about 1/2. There's nothing etched in stone about these measurements. It just depends on what's comfortable for you. A little practice with this will help you decide exactly what you need. Here's a finished example, or roughly finished example of the type of door we want to do. You might have recalled in video 104, basic door construction, we actually put the rabbet on the back of the door. In this case, we're putting the rabbet on the front of the door, and we're adding some decorative moldings. These moldings give us some depth and really enhance the beauty of the door. So, how do we set the depth of the rabbet? Well, I prepared a scrap to test this out. Here's my molding scrap. And if I set my piece of panel stock in here, I can now put that molding on, and you can see that it's going to hold it nicely. This is the exact depth that I need, and I've set the stop on my router for that depth. I'll take it in 2 cuts. In other words, I'll take a light cut, and then I'll use the opposite stop to make the full depth of cut. All right, so I've clamped my panel in this parallel clamp, which is clamped in the vise, and it's securely set up. I've cut the rabbet on this one, and we'll come back to this, but you can see that we've got a nice clean rabbet around here, and we can use that to hold our panel in position. All right, let's go to the routing. There really isn't a lot to it. If you've done some routing already, you may well have. First of all, I've set my stops. I've got a deep or full depth stop, and I want to turn back to the initial stop. This is a lighter cut. This lighter cut then will allow me to take this in 2 passes and reduce the chance that there be any tear out in the cut. So I'll be able to make about half of this around like so, then I'll stop it, change the depth to the full depth, make that cut. Then I can go back to the shallower depth after I change the clamps and proceed to do the exact same series of cuts on the opposite side. All I have to do now is just reverse my stop, and that's going to allow my router to go just a little deeper and finish this cut up. Notice how clean it is. There is no tear out, and that's the best way to approach this. Now I'll reverse this, and you get a better idea of how the cutting is done. So I just turn that like so, position my clamp again, tighten securely, change my setting again, So that's ready to go. Now, we get a radius in the corners because of the arc of the router bit. We have to square that up to accommodate the square panel and also accommodate the miters of the molding, which will fit in this corner snugly like this. And with that little bit of wood there, we've got a problem. So what I can do is clamp this down and then proceed to square these up. I use the clamp pad to keep from damaging the good face of my door panel. And I'll take about a 3/4 inch chisel. I'll just work one of these corners. You want to take light cuts, working heel to toe with the chisel, and then if you need to, you can remove a little of that stock, like so. There we go. You may notice now that we actually see the opening from the cavity from the biscuit in here, or plate joint, but that's not going to be a problem because we're going to add to this some kind of panel like so, and then we'll have our molding on here like this. So that won't be a problem, and we'll make the door have a deeper appearance, a richer look. Work with the chisel carefully. If you have to do any touch-up work, you can make very fine shaving cuts like so. All right, I'll cut panels for these out of plywood now, and then I'll proceed to show you how to nail those in or glue those in depending on what kind of equipment you have. So let me get cleaned up here and get set up, and I'll be right back with those tools. Well, I think you can see we're ready to go. We've got the molding cut, and I think you'd agree that it decorates that panel real nicely. A couple tips and a couple things to think about if you're going to cut these miters. You might already be asking yourself, how are you going to do it? Well, 2 or 3 of the tools that will work well are, of course, the motorized miter box, the radial arm saw, and the table saw. A few tips, however. If you're going to cut any of this molding, you may want to put it on a stool. That is, some kind of piece of wood that will hold it squarely as you're cutting that miter, be it a chopping action or a pulling action. Also, there is a slight chip out here. When working with a motorized miter box, if you lift that cut up, lift the blade up after the cut is made, you're going to find that you're more likely to get that type of tear out. Make the cut, hold the blade down till the blade comes to a complete stop, lift it out, and you'll be much happier with the result. Now, one other thing that you'll have to remember, in most cases in framing, usually we think of the long point of the miter, that is, this being the long point, being out here at the outer edge of the rabbet. You've got to turn your thinking cap around when you cut these, or you're going to be disappointed, maybe not disappointed, but you're going to cut them more than one time. So work carefully and get things fitted so that they will hold together nicely. Now, we could glue and clamp these in, but I've got a couple different nailers here that I will use to nail those in. I want to just share with you a little bit of what they use. This nailer here uses a headless pin, and if we're to look at this, it's just a little blank of steel, and that will drive through here and leave a very, very small hole. If we look at this gun, we're going to see that it uses a small head type or headless. It will use either type. And so we can use either one of these to hold these in, depending on what nailer you have available. This will leave a little smaller hole. In most cases, it's not noticeable because we're going to fill it. Now, where will we be nailing? Good question. We'll want to nail so that we hold this in and down. We'll also be concerned about our miters, so we'll probably do some finessing or schmoozing to get things just the way we want them in those corners. All right. What I'm going to do then is I'll nail 1 or 2 of these in with this, and you can see what happens. I've already got the gun loaded. I have some glue prepared here, and I'm not going to put a lot on. Now, if you had a glass panel in this door as opposed to a wood one, Do you think gluing would be a good idea? Well, I don't, because the first thing you have to think about whenever you have a glass door is that the most likely thing to happen when you glue these in is that the glass will break. So we want to avoid that whenever possible. So I just brush a little bit of glue on there and slip that in like so. And I'm going to work this piece along with it. I'll brush just a little bit of glue in there, not much. I'll slip those in, making sure I don't have any glue on my fingers. Bring those together so they're fairly tight. There's one pin in that corner. Now what I want to do is move this in so I've got a nice tight fit there at the corner, and that's what I'm going to nail to. Now I can work these two loose ones against those to get my corners all looking really sharp. So again, just a little bit of glue down there, not too much. All right, now I'm going to watch this miter, try and pull that snug, get one in that, one here, and now I'll pull these two so they look good. And I'm pretty happy with what's happened. Let me show you the size of the hole, and I don't know how visible it'll be, but it's just a little bit bigger than the point of that pencil. A hole like this really isn't much trouble to fill. If this were a little deeper, I might have been able to go in from the side. But since it wasn't, this is the best I can do. I've got one spot here that's sitting a little high, and I'm going to adjust that right now. And I'm ready to set that aside, do my filling or whatever I need to do. Be mindful of your panels. If there's a warp to them, they can cause problems. Push down on those all the way around to make sure they sit nicely. All right, we've been through the process of making this molding, and I want to show you a couple other doors now. This one is set up using the same species of wood for the frame as the panel. We've added a bigger piece of molding, that is, there's more of a rabbet to this, and I think you'd agree that as you look into this door, there's depth. More shadow, more line, and even though we're using 3/4 inch stock, we have the expense or the richness of 5/4 or 6/4 stock. So this is one way we can make something inexpensive look very nice, a matter of a few miters. Again, here's another one using a little different approach. When we compare these two, we see one extra dimension of that, and that is the raised panel in the center. We haven't talked about that yet, but we're going to get into some ways of making these raised panels on your router table and show you that as part of router door basics. So we'll get into that as well as a few other setups here later. Right now I'm going to clean the bench and get ready to fill these holes and prepare to move on. So we'll be back in a minute. We've set up this router table to cut a slot in our piece. This slot will be used in just about any door that we work with, and that will contain the panel, be it a raised panel or a plain panel or any number of other things, tin for example, or cane. To do this, we put a spiral router bit on. This spiral router bit acts much like a drill bit and pulls the chips down. We've also set up these two feather boards, and their purpose then is to hold the piece against the fence and also act as a bit of a brake should there be a kickback. With the spiral action of the bit, that's not likely, however. So these will actually hold the piece, and so there won't be any kickback action. Now, if you've got a good face on all your pieces, it's important they be centered, but it is a good practice to set that good face against the fence on all your parts. Now I've lined up some parts here, and I'll begin to cut those in a minute. But one last thing that I would like to point out is I've set the bit for 1/4 inch deep, and I actually want a desired finish depth of 3/8. The reason I've done that is it's best to take it in 2 passes. 2 passes work much better because there's less stress on the bit. There could be a lot of lateral stress on that bit if we tried to make all of that cut at one time. Lateral stress can be a real problem with any router bit, And as this piece goes through, if we were to take that full 3/8 in one pass, there would be the type of stress that could actually damage the bit. So we'll take it in a 1/4 inch bite first, and then we'll proceed to take it an extra cut and raising the bit 1/8 of an inch. So I've got some of my parts ready, and I've set them up so all of the good faces are in one direction, and I can proceed to cut those. I'll only cut a couple of them to give you an idea how it's done. This setup is something you could set up on any of your router tables quite easily. Procedure's the same for all of the parts. We want to make sure we've got her centered. We could check now. If there is any deviation, we can make those adjustments. So as I check this, it looks like I could adjust that fence just a hair and proceed. So I'll do that and wrap this up. We adjusted the fence so we are centered, and you can see that we've now got our bit set to the full depth, our 3/8. And all we've got to do now is proceed to make those cuts on the remaining pieces. Again, we want to keep the same face against the fence so that we don't goof things up. If we're off just a little bit, it is a bit of a problem, but if we double the error by flipping it around, we've got a real problem. So I'll cut these, and then we'll proceed to the final steps. There's the full depth of cut. Now we can do a number of things with this. We can proceed to make some tongue and groove joints or miters and so forth. And we'll be discussing those as we get into those scenes. So you can look forward to seeing that. In our last setup, we cut this groove using a 1/4 inch spiral bit. We've got a 1/2 inch spiral bit set up now, and we've got its height so that it will actually remove all of the stock that forms the groove, leaving us with a tenon. The tenon that's formed here will actually be the part that joins the doors together. Now, a few things to know. First, the distance from the end of the board to the shoulder is 1.25 inches. We've set that up from the outer edge of the bit to that fence, and we've also made sure the fence is parallel to the miter slot so that when we feed the board across there, it always stays in contact with the fence. Now, the height is adjusted, the fence is adjusted. We've got to now decide what to do as far as our pieces go. We'll take our rails, and our rails will get this cut on both ends, on both sides. Now, to make this just a little safer, we can add one extra precaution or one extra barrier here. And all this is a piece of wood that's going to act as a barrier between us and the cutter. And we'll just clamp that down with a couple of C-clamps once we have it positioned. And we can proceed to make this cut. the tongue is just right, or the tenon is just right. It's just a little sloppy. It will fall out of there, and that's fine. Now, the next step is to make the haunch on this piece. And if we were to line our pieces up like so, we'd see that that pencil line bottoms out on the bottom of that groove. That actually determines where the haunch needs to be, and it has to be a 1/2 inch deep, so that when these two pieces are pushed together, the mortise and tenon joint is down here, the haunch is here. Now the reason we have a 1/2 inch is so that if we route a rabbet around here to make a rabbeted door, we don't cut into that cavity. This is very important. If you're curious about this, you may also want to look at VW204, Advanced Door Construction. We show you some of these setups in detail. So I'm going to now stop, break down this setup, and change to make the haunch. We're ready to cut the haunch on the tenon now. And what we've done is we've laid it out and we've set it up so that we're going to remove that notched area. What will happen is this stock will be removed. Now it requires 2 passes. Earlier I butted the piece up and made that cut. The drawback here is there'd be a small piece of stock pinched in there that could kick out. So what we'll do is we'll start away from the fence and then make the second cut at the fence. And we'll do this on both ends of the rails, haunching the tenon on both ends. So again, we'll put the stop up here, clamp it in position so that we stay clear of the cutter. And remember, we don't start with it butted at the fence, but rather about 1/4 inch away. We've got the haunch cut just about on the layout line. There's a little remaining of the layout line. Now there is a little bit of tear out on the back side here, and we could put some kind of backer in there if we wanted to, although in most cases just a couple brisk moves like so, remove that fuzz and make it just like new. All right, so that's the haunching. Now, one of the things we'll have to do later is put a slight radius on here or square out the mortise into which we position this, and we'll show you those techniques later in the setups. Another way of making a tenon is with this rigor mortis device. Our router will ride across here and we'll shear through here with our cutter. This cut that's already been made with a router bit determines where our shoulder should end, and this stop here has been locked so that that shoulder can always be found on repetitive cuts. I'll go through this real quickly and you'll see exactly how it's done. That would cut one side of the tenon. Next I would loosen this up, flip it over. I've already cut the other side. This would slide in again, and of course the end would have been caught by that same stop. So now we've got both sides, both shoulders formed, and the tenons ready for additional operations. The mortise and tenon joint is a two-part joint, and you've seen us make the haunch and the tenon itself. Now we've got to make this cavity or groove into which it's inserted. One of the ways that we can go about that is first to mark our stock, and what I've done is I've lined up the tops here, and as I bring that back you'll see these two pencil lines determine where the cavities to begin and end. This is a good way of laying out my stock. In this rigor mortis jig, I have that same piece lined up exactly like so with my two marks. I've got a plunger outer set up with my depth already predetermined, and I've got to go in a 1.25 inches. To center this, I've got these two pins that drop down, and as long as I ride along there with my two pins, I'm centered and I can make the cut. So I've got to keep my eye on the bit here to make sure that I'm set correctly. Little tight on that side. Perfect here, which suggests there's going to be a little bit of custom fitting that needs to be done with each of these corners, and when we get back to the bench with all these parts we'll talk about that custom fit and how we set these up. There's also more information about this in video 104 or video 105, Advanced Door Construction. We do this with a table saw and radial arm saw. So if you want to check for more information, go there. We'll show you how to fit these at the bench here in a bit. Mortise and tenon joints are real important to the door construction, and one of the most important parts of it is the fit between the parts. This one fits pretty well, but if we try to fit this one in here, we've got a problem. The problem is these corners haven't been cleaned up yet. We've got to have a radius on there so that'll fit the cavity. And there are a number of ways of doing this. Right now I'm using a rasp-like device just to knock that down, make a corner out of it, or round it off to make a radius around there. Now I could make a sharp corner inside those cavities, but with the tools I'm using and the router bits and so forth, it's easier to cut this radius on the part. That's more like it. That's the kind of fit we need. There's just a little bit more interference down at the bottom. We can clean this up a little bit. See if there's a little residue in there. That's a good one. And that's not bad. I can look for a shiny spot now to see what the fit's like. Once I get that fit, my parts will all go together, joined something like that, and with the clamps, little final work, I'll be ready to go. So fit all of your pieces like this, and then you can measure your panel and start to cut your panel. Your panel length will be just a little short of the distance from that shoulder to that shoulder to allow for expansion and contraction. So keep that in mind when you start to cut the panels. Another good door joint is what we refer to as a stub mortise and tenon, or what looks like a tongue and groove joint. This type of joint is very useful in making a door up. One thing about these is the depth of penetration, and I'll just stack these two one on top of the other and call your attention to the depth of cut here. Notice that this one is about twice as deep as the one beneath it. In this case, we're going to have twice as much glue joint strength here because there's a lot more bonding area. And And when we make a joint like this, we would probably also pin it to give it extra strength. Now, the first thing that is made is the groove, and the groove is formed on all of the parts of the door, both the rails and the stiles, the vertical parts being the stiles and the horizontal parts being the rails. To do this cut, we could use a technique with a router bit on edge, or we can also use a slotting cutter. What I'm going to show you now is how to do this with a slotting cutter. A slotting cutter is a piece of steel that cuts a slot. In other words, instead of feeding the pieces vertically and having a cutter come through, we'll feed the pieces horizontally like so. And I think I've got a piece prepared here that will show you what's happening. This piece would actually go through here, something like this, with the guard in position, and the cut would be made. The slotting cutter works much like a saw blade does to make that cut. Now, in working with this, it's very important that you have the bit centered on your workpiece. Otherwise, you're going to have to make two different cuts when you form that tongue. One height for this side, another height for the other. So it is important that you decide that early. This bit has a 1/2 inch collet to reduce deflection. We've got a couple feather boards set up to work with the stock. And in some doors, we may have some stock that is only about 8 inches long for the rails. It is best, however, to slot those as pieces that are about 16 inches long, like you see here, because this gives us more control and an easier and safer way of dealing with the stock. We can then cut it in half afterward. So don't cut these into small pieces until you've actually made the groove or slot on the edge of the pieces. Now I'll demonstrate the technique. There's really not a lot to it. We've got the fences in a straight line, and they're aligned in the same plane as the ball bearing. In other words, the ball bearing and those two fences are all in the same plane. This gives us the full depth of cut. The size of the slot is about 1/4 inch wide, and it goes in about 3/8 to 7/16 deep. Select your stock and decide whether the good face is going to be up or down. It's important that you know which way it's going to be, because if you have these reversed as you go through, then when you put the door together, there's going to be some offset. So make sure everything's set before you turn on the machine. I'll turn on the dust collector first. We've got our groove cut now. Our tongues are about even. It's like this could drop a little bit, but there may be a slight twist in the board. As you work with your stock, you'll start to notice those things. One thing I wanted to point out, we were able to work with that guard using a push stick that allowed us to work under here, feed our piece through, and still pull out. So there are ways of working and devising jigs and push sticks that'll make the job safer, and I'd encourage you to think about those things every time before you work. Now it's time to start thinking about the tongue and some other cuts, and we'll get back to that in just a minute. We had set up to cut these grooves and talked about putting that tongue on the ends of the pieces. I've repositioned the cutter so that I can do exactly that. When I bring the cutter up, you'll notice that it's now cutting away all of the stock below the groove. I've got this piece of plywood and this backing board made up in an L fashion, and its purpose is to elevate the piece so the cutter doesn't drag on the table. Another feature is that I've got this wood back here to act as a backer, so that when the cutter comes through, it doesn't tear the piece of wood I'm working with, but rather tears into that backing piece. Also notice the cutaway there. It allows me to use the guard and work safely as I go. So, in working with this setup, I'm going to collect the dust. All of the rail ends will get these cuts. There's a little fuzz here which suggests that either the piece is a little thicker than 3/4 or my cut's off center a little bit. I can knock that fuzz off real simply, just like that. And I get a nice sharp edge. Now I've got a little fuzz there. I'm not going to worry too much about that yet. Let's get the other end here. That'll be weak there. Should break off. That's fine. One more time. Okay. Now as I insert that into one of the mating parts, I find that the fit is pretty good and the balance is there. Now you don't want it so tight you have to force it together because then there's no room for glue. If it's a little sloppy, in other words, this will fall out of there. But when we add the glue and pin it, that's going to be a very, very nice fit. So I'm pleased with what I see here. I can go on and cut all of the others. And I'll do that here shortly. Now imagine grooving these and putting the tenons on, getting a nice strong corner. There are other ways we can go about it as well. And one of them is to, instead of use that tenon, go with a miter, so that now we've got a groove that goes in through here, and we've mitered these pieces together to make a very detailed door. This will take about 3 or 4 extra cuts to make this up. In addition, you'll have to cut the miters. There won't be as much strength in the end grain here, but we could spline these or put some kind of pins in the corners if we decided to. This is another step extrapolating on what we've discussed here. So let's go to that step now. Earlier we talked about transforming a piece of stock like this that had been grooved into a molding that could be mitered and formed into a frame. We're going to now look at the techniques for doing that. One of the first cuts, there's actually 2 different bits used, and the first bit is on the router now. And we're going to make this cut going in like so, and then we'll flip the piece over and make the same cut. That will give us these 2 beads, and there'll be 2 flats out here. The outer one will be removed later. One thing I'd like to point out, here's my setup piece, and if you look at this you'll notice that there's some mill marks down the middle. The reason there are mill marks is that no stock is removed right on the center line. This ball bearing is lined up with the fences and rides on that spot. So it's very important your stock be sanded and trued up, unlike this setup piece that we have here. So keep that in mind if you use this setup. First thing, sand all your stock true on the good faces and make sure that you have the good faces oriented so that you don't have that problem. We've got one more cut to make. We've gone from flat to shaped, and now we've got this beveled back to cut. We're going to stop for a second, change bits, and proceed to make that cut on all the parts. So we'll do that now. Didn't take long to change that bit, now did it? The next step is going to be to cut this radius on the outside edge. And this is the cut. There's the setup we'll be using. Now it's important that you remember to keep the groove side out or away from it. In other words, the groove's got to be on the inside edge of the door, and we're going to cut the bevel on the outside. One thing that we might be able to do is work with a guide like this if we weren't using a push stick, rather a push block. But I'm going to use a push stick in this case to feed the piece and keep my hands clear of the cutter. So, after all of our stock is cut like so, with this radius on here, we've got the pull for opening a door. And from here we can now proceed to miter the corners and make up a frame door, such as what you would see here. So that's the last step other than mitering. Your choices of mitering are mini, chop saw, or motorized miter box, table saw, or radial arm saw, depending on what you have available. So use your ingenuity and take it from there. We've made this up as a door, and I think you'd agree that there isn't a lot of line to it, a nice flat panel, a lot of flat to it. Not a lot of interest here. One way to make it more interesting, of course, would be with a raised panel. If we didn't have those capabilities, however, we could add some line by doing something like this. Note the chamfer lines that go around the raised area, or the opening where the panel will go. These chamfers will give you a little more interest around there. Now the question is, how might you go about this? Well, on this panel, it may not really be easy to see, but there's a little line about 1 inch in from each edge of the corner. 1 inch this way, 1 inch this way, in all 4 corners. And those are the lines where we want that chamfer to start and stop. Notice that if we come up 1 inch, we come up 1 inch this way, the chamfer stops. We go over 1 inch this way, the chamfer stops. This is a stop chamfer, and it gives us a little more square line, calls attention to what's there. So if we're going to make these up, it's actually pretty simple. First, we'll separate the parts. And I'll clamp one end like so, far down as I can, and still have good grip on it. Next, what I'm going to do is I've set my router bit, which is a chamfering router bit, to cut that line. Now, I'll have to be watching what I do, because I want that cutter to start the arc right at that pencil line. So it'll take a little concentration, and remember, I could start in here and ease back a little bit, which would be far better than making an error. There's the cut right at the chamfer line. Now all I have to do is move the piece. Cut is ended right there at the pencil line again, and proportionally they're exactly the same. Now, this procedure would be repeated 4 times for each of the 4 parts. Once that's done, we're ready to glue up. This door that I have ready to glue up, I'm going to do one additional thing with it. and that is I'm going to add a panel that's already been stained. By putting this panel in, I don't have to worry so much about expansion and contraction because the entire panel is stained. That is, if it shrinks a little bit, that's not going to be a problem, is it? The panel is already stained all the way out to that very edge. So, with that in mind, I know that things are going to fit. I've prepared a little glue here. I'm going to just brush it on my tenons. Slip that in like so. Make sure I know which is the good face, because there's a good side to the plywood just as there is a good side to all of the parts. So I'll get those positioned. I'm not worrying too much about the end grain, just that face grain, because face grain to face grain gluing is the strongest, and end grain gluing really doesn't give you a lot of strength. Put that down on the panel. Position that accordingly. Now I can just brush a little bit on these two sides like so. Ready for the other side. Fits quite good here, but I'm going to just snug this up lightly, making sure that everything's flush across the top. Do the same on the other end. Now I'm going to turn the door upside down, and we're going to anchor it with a couple pins. The pins will go here and here. The pins that I'm shooting are not long enough to go through the door, or rather when I shoot them they will lock the parts together, like so. Do all four corners like that. Now I can remove the clamps, because those pins now have been shot through the tongues, holding that door in a rectangular fashion, nice and snug, no racking, almost like a steel dowel. Now, if you don't have this capability in your shop, you could actually use some small nails. What you would do is cut the head off them, chuck them in a drill motor, drill through, and then drive them. I show that technique in my video 101, so you may want to check that again if you're not sure of how it's done. Well, that's how we get this door ready to go, and I think you can see the line. We've got some nice chamfers, nice decorative look. We'll call this a wrap on this door, set it aside for the glue to cure, and then we'll come back and take a look at it again. Well, with a little work I was able to fit this mortise and tenon door together with the plain panel in it. We could cut the chamfers that we talked about earlier to kind of give it a decorative look. But do you think that's enough line? After you put all that much energy into making this mortise and tenon joinery, I think it's important that we add a little something to it. Perhaps a raised panel like this. We can raise this panel in a couple different ways, and we'll talk about how that can be done inexpensively as we get into this tape. So, be thinking about how you want your doors to look, a little more depth perhaps, a little extra line, and we can go on to making them just like that. We're going to make some raised panels with a little bit different approach. Today everybody looks at all the equipment you can buy, and we've taken a more of a low-tech approach to making these up. One of the things we've done first off is we've set a fence that's actually at an incline 6 degrees toward the bit. The bit we're using is a 1/2-inch spiral bit. We have all of the exposed cutting edge actually up above the table. We can use a full-speed bit with this. That is, we can use a router running at 18 to 20,000 without a problem. We also have a push block that'll sit on here that's a saddle to help us guide this through the cutter. In addition to that, we're going to add one feature, and that's dust collection. We've made up a rain gutter piece here that we can use to pull the chips away from the cutter as the work is being done. This additional dimension helps reduce the bumping and jolting, takes the intimidation out of the job. Another feature is this feather board. The feather board allows the panel to get through there, but I think you'd agree it's pretty difficult to get your fingers in there. Not impossible, but difficult. The idea is we have a barrier here, and we also have a holding device that holds the panel in. Before we made this feather board, we cut a bevel on the front edge of it that runs parallel to the face of this fence so that it is in total contact. The piece will go through something like this. First we'll do the end grain. We'll use this push block to guide our piece. We're taking a relatively light cut. To make this work, you should take 2 passes around the panel. So what I'm going to do is turn on the dust collector and get ready here, and we'll go ahead and make this cut. We've got our nice miters formed here on the corners, a nice crisp shoulder around here. We've taken most of the stock out, and we've got just a little over a 1/4 inch shoulder here. Now, if this is going into a 1/4 inch groove, we'd have to remove just a little more stock, and that would be that light cut we'd need to fit into the groove of our mating panels. So from here, all I really have to do is adjust that fence. If I found that I was getting too much wedging action pushing this into the groove, and it's only 6 degrees, I could do one of 2 things. I could put a slight bevel on the backside with a plane, or I could take that same spiral bit and cut a square cut along here so that it would fit the groove. Now this approach to making panels eliminates all of the speed controllers and all of the other extra gizmos that you need. Take light cuts. Again, you're working with a solid carbide spiral bit, which does an excellent job and machines very well even under heavy conditions. The light cleanup cut would take those few ridges out of there, but beyond there, this is just about ready to be stained and finished. Very minimal sanding, if any. It is important, however, that you have the center of your panel already sanded, because if you start to sand around here beforehand, what you're going to do is lose those nice crisp shoulders we formed with the cutter. So this is an approach to making panels inexpensively. We'll take a look at some others during the videotape, but here's one that you can do with a minimum amount of equipment. We've set up now to raise panels with a vertical panel raising bit. You can see the bit there up close, and what it's going to do is cut a cut. It's very similar to that. It's a little different than the one we used for that setup. I've got a feather board here just about positioned, and I can bring this in and you can get an idea of what's got to be cut. The pencil line there is the mark for the groove into which this panel must be inserted later, and that's our measure of our most important measurement. The panel is approximately a 1/2 inch thick. It's been planed and sanded both sides. I'm going to just turn this feather board in and snug the clamps up. The idea here is that we've got 2 things going for us. First, the feather board is going to hold that panel perpendicular, and second, it's going to act as a barrier between us and the cutter. I've got dust collection set up here, and I think that's very important to the overall success of this operation because it takes some of the bumping and intimidation out of the cut. Also notice this push block here, which goes through like so. The push block controls and backs the piece up, particularly when I'm cutting the end grain, which is usually a little more difficult to do. The reason for that is there's more likelihood of tear out. Our most important measurement is how does that fit the groove. It fits nicely, I'm satisfied, that's what I need to work with. The quality of the cut along the end grain is very good. If I were concerned that it wasn't quite good enough, I could take just a slightly lighter cut and then come back and do this cleanup. But I'm real pleased with the miters across the corners and the overall quality. So I'm satisfied with that. I'm going to continue to raise the rest of those panels. Here's the part we've been waiting for, to glue up these raised panel doors, and we've got a couple examples, one with a miter and a raised panel, the other with mortise and tenon and a raised panel. The panels have been already sealed because we want to seal all the way over the edges so that if they expand or contract, we won't see something that's unfinished. I'm going to get some glue ready here, and I'm going to brush that into these mortises. I'm going to start with the mortise and tenon door. When gluing, it's best to wet the wood. We could just let this squirt in here, but a much stronger bond occurs when you wet the wood. And so that's why we're going to take the time to brush this on. I'm not putting any on the shoulders. Any squeeze out will come out down there. And anything that's excess would just be a problem and spill out onto the face or stiles and rails of the door, something that I'm really not too excited about having happen. So now I can move this piece. Got that side fitted. Push it together like so. I do have a bit of squeeze out, not enough to give me much of a problem yet. I can use my hammer to tap things into position if I want. I'm going to just lightly pull things together here. I'm watching the shoulders to make sure that they bottom out nicely, and I'm checking along here, see if things have to be lined up. The next thing I want to do is work my miters, and I've got end grain gluing here, which I already said wasn't very strong, but we can reinforce this after the glue sets up if we like. Good to wet that end grain so that you get good strength, because the end grain tends to absorb the moisture in the glue pretty quickly, so I'll wet both of them pretty well. Push them together, let them start to work. All right, now I'm going to use a band or web clamp, as it's sometimes called. Provided I get it untangled. And I'm just going to set it around here lightly like so, and then pull on it. Now there are some things to remember when you work with these clamps. First of all, you don't want to have it like I've got it with the tightening nut down. So we'll turn it over. And second of all, you don't want this very close to either edge, because as you're starting to tighten it, it will start to creep that way. Okay, I put some tension on it. Now I'm going to help those miters find their fit, find their alignment, and put a couple more turns on here. All right, so the door is set, and I can set that aside for the glue to cure. Now let's go back over here for a minute. The glue is starting to set up, and what I'll do is take a chisel and just pick that glue up as a residue. The next thing I want to do, now that that's cleared off, you can see there's no residue there. Let's take a look at the back. That's pretty good. Now I want to pin those miters, and we talked about that earlier. What I want to do, or miters, pin those mortise and tenons. I'm going to drive a 5/8 pin through that mortise and tenon joint from the back side, all four corners. What's happening now is we have a dowel, metal dowel, holding this together. When I release that clamp, there should be no movement of those parts. Now, you want to keep those pins away from the edge of the door, because later, if we decide to put a radius around the outside edge, we don't want those pins up here where they could get in the way of the cutter that we're working with. See, just a little bit of glue there. Okay, I'll get that off. Now, we talked about how about the panel being centered. If I look at this panel now, I can do a rough measurement and say, how close to that am I, and get dimensions. And it looks like the panel could go this way just a little bit. Now to make that move, I'll take a softwood block, put it along that edge, and just tap the panel, tap that board, and drive that panel over. Now I can check those dimensions again to see what's happened. Side to side it's about right. Now let's see what we've got here. Okay, my reveal is the same all the way around. Now to make that panel stay in the exact middle, what I'm going to do is go to the back side, and I'm going to drive a pin on the center line, top and bottom. This pin will go through right here, right here. What that will do is freeze that panel exactly on the center line. So if it expands and contracts, it can never expand all the way over so that you might see light over here. The exposure will be exactly the same on both sides. Now, if you didn't have a pneumatic nailer, you could drill a small hole and drive a brad through there approximately 5/8 long. What happens is that brad does not go all the way through. It only goes blindly from the back side into the front and does not kick out or tear out. So we've actually locked that in. We've got control over the piece, and we've got everything we need for a nice fitting door. Remember again, keep those up away from the door, because if we decide to edge this, and we'll probably be doing that shortly, we'll want to be in control. Now the panel here can be adjusted exactly the same way, just a matter of using that softwood block again and a tapping action. I can tap that around. Now I'm going to wait until the glue sets up to pin that. These miters, again, are not the strongest joint. I could put some kind of spline in the corner to reinforce those, or I could drive a pneumatic nail perpendicular, 2 nails, one from each side, to make that nice and tight and nice and strong. So that, in essence, is what it takes to glue up and do a nice job with the panels. Remember, this is one of the most important steps. If we put all that action in here already, we want to make sure that we showcase it nicely. So take your time with this, brush the glue on, do a quality job. You'll be happy you did. Well, this door turned out really well, and any door that you make from the Video Door Basics or Router Door Basics tape will turn out equally well. Follow the message, review it a couple times, test your setups on some scrap, and then move on. Remember, if you want to become a better woodworker, you got to do more woodworking. good to have a storage place for those expensive bits when they're not in use. In fact, that's kind of why we made up that nice base and the router table. If you've been admiring these during the course of the video, we'd like to tell you about a set of plans that are available for these. Many of my friends and students like this as well. They asked about the plans, and so we developed a set that are available now. There are 5 pages of prints here and a lot of options that you can use no matter what type of router table you'd like to make up. And there's plenty of opportunities to try your router skills in making this up.